So, we are coming to the end, and I have invoked host privileges to override the Pachacocha. So I will be controlling the presentation myself, but I will try to stick to the 10 minutes or 6 point somewhere minutes. And then I will thank Nomi at the end. So we've heard many things today, and I thought it would be time for something different. And the difference has to do with our being an institute of technology here, and focus a little bit about technology in terms of, thank you for the lovely music, something that has to do with the future more than the past. Before I start, I would just like to mention the many contributors to this research. As you can see, the many institutions that are involved, the Technion, Sapienza University in Rome, UC Berkeley, Rogers firm in California, Sutter Health, Netzion Medical Center, and most recently, Soroski Medical Center. The issue that we're dealing with has to do with foreseeing the future. In other words, we have heard many talks today about gathering experience in order to use it, to reuse it in future designs, in terms of master plans, in terms of databases and user experiences and so forth. The main question is the design that the architect envisions really going to pan out? Is what he thinks or she thinks is what actually is going to happen? Because all these experiences that have been gathered are basically looking in the rear view mirror. This is what was, what happened in the past. And then we design something new and hope that it will work as expected. The question is, will it? We have seen many pictures like this of different emergency rooms, but really, in reality, they look like this. We've seen corridors. Several of the presenters have presented them, but in reality, they look like this. So the question is, are what we designing going to work the same way as we envisioned it to be? A bit of theory. After all, we are in an academic institution here, so we can do that. The design process usually is considered to have three major steps. One is the conception, the other one is the representation of the idea, and then its evaluation. This is a cyclical process that we go on and continue to do. One component here, and that's why I'm using these overlapping circles, is prediction. Between the representation and the evaluation comes an element of prediction. This is what we are doing, this is how we represent it. Now, will it really work? And how do we know? We have seen predictions in many areas of architecture, structures, energy, acoustics, even emergency egress. We can simulate and see how it works. The one thing that we have not done very well, except by rear view mirror, is predicting human behavior. In other words, we assume that we know how people behave or how they will behave in our environments, but do we really know that? This is a quote from a colleague in the United States, Brian Lawson, who says, the best test of most designs is to wait and see how they really work in practice. That's a little bit late in most designs. After we have spent $300 million to find out that it's not exactly what we have thought, that's not acceptable. Predicting human behavior is very difficult. It's made of many different components, psychosocial, it's highly context dependent, dynamic. I won't go through all that stuff. You all know that. And still we have been doing some of that. We have been modeling the behavior of individuals. What you're looking at is a fire egress simulation or prediction. Assume that fire breaks out in one of the rooms and people have to evacuate. We can model that. We have tools, computer science have developed tools known as agent-based models to do that. They've even been imported or attempted to be imported into the healthcare area. As you can see, not very successfully. Look a bit cartoonish. There is even a commercial system that you can buy called SimCAD, suffers from the same problems. The main issue that we have identified was that many of our actions in the world are not individual actions, but group actions. So here is a girl having lunch. It's quite a different affair when you have a family sitting down to have dinner who have decided to meet at the same time in the same place to do the same activity. It's not individual anymore, it's a group behavior. And we claim that group behavior is not the sum of individual behaviors. So we are focusing on this idea of modeling group behavior and then trying to simulate that and to use that for predicting the future. The three main components that we use are people, activities, and spaces. In other words, there is a space where people gather to do a certain activity, and then we implement that in our environments. The thing in the center is called an event, and we call it an event. You put together a bunch of events, you get a scenario. So you have certain people doing certain things in certain spaces, and that leads to other things. It can become very complicated very quickly, and when you try to map that out, so it becomes a network of activities, people, spaces that lead to other activities, and so on and so forth. We have employed the method of observing the real world, trying to package these things into what we call an event, and then take it to the virtual world of the simulation and unpack it and make certain things. The data collection is done the usual way. We go and observe and ask questions or get the help from the medical facility where we apply this. And we get these very complicated schedules, what the nurses do every hour of the day, and so on and so forth. Then we can take all that stuff and put it in a piece of software that we have acquired that help us map it out in a computationally treatable manner, and then we can feed it into a simulation engine. Here's an example. This is the Alta Bates Summit Medical Center in Oakland, California that participates in our research. It's a new facility that is it constructed yet, or is just under construction? This is that part of Oakland. This is the building, and this is a typical floor award in that area. We focused on modeling the people, not so much the environment, which we got from the architects. So our attempt here is to see how people actually use that which has been designed. Of course, this is a bit cartoonish. This is primarily a matter of time and money, how refined we want it to be. And what you see here is the behavior of the staff and the patients and visitors. These are not animations. That is, we did not make these people walk a certain route, predicted route, but rather there is an element that we call an artificial intelligence in this thing, which allows these entities to find their own way. We give them a mission or a target to go to, and then they find their own way. They can avoid each other. They can avoid doors and walls and so forth. The idea is to try and see if the design actually is efficient and contributes to quality. So we are looking at design aspects that affect the satisfaction of the people who are using this and the management of the entire thing. This is an example here of two alternative designs for the same ward. You can tell the difference is this part. Here it's integrated within the environment, and then it is separated. And we can just put them side by side and see how people behave in both of them. Which one do we like better? This is from the left one is from Bnei Zion. The right one is the one that we have modified. Maybe they will like it and implement it, we don't know. But this allows us to see the space in action, how it will actually be used. In some ways, this gives us the same overview that air traffic control has been practicing for many years. This is a view of all the airplanes above the United States at a certain moment, which is what the FAA does. So they can tell what is going on everywhere, not just the individual one. So that's the same idea with having an overview, a functional MRI type thing of the building. We can track individuals, we can track groups. That is, we can put kind of meters on the visitors, on the patients, and see how much time they spend here, how much time they spend there, and get statistics out of that. We can do the same thing for the staff and see what if we change the schedule. How will the new schedule comply with the spaces that we have provided for them? We can test emergency situations when we accelerate certain aspects or trigger an emergency, a code blue in one of the rooms, and observe how long will it take to get to room 4 compared to room 7 in the same floor. Is it acceptable? We can even track the satisfaction of the staff, see how far or how many kilometers they walked during the shift, how tired they may be. We can put all these measures on them. Of course, it's based on experimentation and certain assumptions, but it will give us a kind of an in-depth view of how the design actually does or performs what we're trying to do. Again, this is a Bnei Zion Medical Center here, where we have started to implement some of these views, and you can see this is the cardiology department, where we have these characters running around. They're called doctors, nurses, patients, visitors, and each one has a certain task to perform. The model is more focused on the people rather than on the environment, but the environment is that which controls, to a large extent, the behavior of the people. So, with that, I will leave you and say thanks.